Okay. Hello, everyone. Can you hear me? Welcome to the AWS Developer Theater. We still have a few seats, so come over. We are starting in a few seconds. So I'm Alex. I'm a technical evangelist at AWS. And today I want to tell you a little bit about how you can speed up and increase the productivity of your product development as a software or as a development team in the cloud. So we'll talk about serverless computing. We'll talk about continuous integration and continuous delivery, what it means and how it affects your workload and your pipelines, your coding pipelines. Let me tell you a little bit about me, what I do. I'm a software engineer. I've been a web developer, and I work in a startup environment for more than 4 years between Italy, Switzerland, and California. So if you have questions about that, I can take questions about startups too. I'm really into serverless. I'm really into AI and some of the very cool technologies that we'll talk about today, tomorrow, and the day after tomorrow in this theater. I've been an AWS customer for a few years, and before we go on with the agenda and what we are going to talk about today, I want to ask you some questions about you. So raise your hand if you are a developer. So this one is easy, 99%. OK, now keep it up if you work for a startup or for a totally new product or something new that is not up there yet. OK, 30%. Keep it up if you think that development productivity and speed is critical to what you're doing. Cool. That's why we are here today. So you are in the right place. Again, I'm sharing with you some insights about serverless computing and why it matters for you if you're not already using services like AWS Lambda in the AWS cloud. I want to share some patterns, some best practices, some tips for you to get started quickly and to increase your productivity as soon as possible. And then I want to share tips and tricks about continuous delivery and what we call internally safe deployments, about deploying safely, allowing you to sleep at night, for example. That's a good feature. And then I want to show you a demo of what this all looks like in the cloud. So let's start with the basics. What is serverless computing? Are you familiar with AWS Lambda? Raise your hand. AWS Lambda, anybody? Cool. So these are 35%, not bad. So AWS Lambda is our function as a service offering. So with respect to traditional compute services or compute approaches with serverless, basically you can kind of forget about the underlying infrastructure. So if you were used to starting a new virtual server, a virtual machine, or even buying physical hardware, I hope you're not doing that anymore. But if that's the traditional approach with the new AWS Lambda serverless approach, you just forget about the underlying infrastructure. We take care of that for you as the cloud provider. So what's left there for you to do is to provide your code. And we'll make sure that your code scales horizontally, that your code is executed. And one of the main benefits is that since we take care of the infrastructure, you don't have to pay for that. It's there waiting to be used by your functions, but you don't pay for it until something actually happens. So your functions, your AWS Lambda functions, will scale up as needed based on the load, on the traffic, on the web views, on whatever your Lambda functions are doing. But they will also scale down to 0. So that's why we say that you never pay for your idle compute capacity, that you don't really care, especially if you are a startup or if you have a brand new product. Maybe your users are not using it 24/7, right? Maybe you have spikes. Maybe you're doing live demos with webinars, and you want your product to scale up nicely without worrying about that, especially in the startup phase. So we like to say never pay for idle, and all the availability and reliability, fault tolerance, will take care of that for you as well. So Ian this morning, an hour ago, talked about AWS regions and AWS availability zones. So those are the physical data centers, the physical places where you can go and spin up new machines and servers and services. With AWS Lambda, we take care of making sure that your Lambda functions are provisioned in more than one data center, so that even if one entire data center goes down, your functions are up and running. We make sure of delivering the requests to the functions that stay up. So that's on us. Another very important key concept of serverless computing is that you can start thinking of events. So you don't think about processes and machines just waiting for stuff to happen, maybe through a socket or through a HTTP request. So with AWS Lambda, you can finally think and design your infrastructures for events or in an event-driven fashion. So as I mentioned, your code doesn't even exist until there is something to process, until there is some event that triggers your Lambda functions. Okay, only then your function will be injected into some sort of runtime or container. We take care of that. And it will be given the event that needs to be processed. So events are everything. Events are HTTP requests are events, or it could be messages coming from a message bus. It could be a new file has been created in our Amazon S3 simple storage service. Okay, you can trigger a Lambda function when a new file has been triggered. And another great thing is that you can use basically any programming language that you are comfortable with. So you can think of Node, Python, Java, .NET, Go, even even PowerShell recently. So I'm personally a Node.js and Python guy, but you like Java, you like Go. Okay, bring your own language, bring your own libraries, bring your own dependencies, and they will run on Lambda. And the good thing is events will trigger your Lambda function, and your Lambda function will be able to interact with third-party events to store data into database. So you can do and implement any server-side logic, even if there is no more server anymore, right? What are the use cases? Almost endless. Okay, so we start from websites to mobile backends, IoT backends, all the way to real-time data processing or data ingestion. If you need to manipulate or validate incoming data, maybe also coming from a mobile or a web application, you might use Lambda to back a chatbot application. I don't know if you're familiar with Amazon Alexa, so if you want to implement an Alexa skill, the backend is probably going to be a Lambda function as well. So it makes it very simple, very easy, very scalable, and also very stateless. That's one of the keywords that we'll say a lot today. Other scenarios, more maybe not in the application layer, but maybe more about IT automation. So if you are more into the operations, or maybe you're a DevOps and you want to automate or monitor your infrastructure, or just even do something like a cron job, maybe just schedule something to happen once a day, once a week, once a month. Okay, you can also do that with AWS Lambda. Let me tell you a little bit about who is using Lambda. I'm really excited to share with you that with respect to when we started. So Lambda was announced in 2014, and then we finally had the first meaningful integrations like API Gateway and SNS and S3 in the next 6 to 12 months. And I'm really happy to share with you that now, today, 9 out of 10 of the largest AWS accounts, customers, are using AWS Lambda. So we have seen that shift from just a new way of doing minor little features or little enhancements to your system to major best practices into building these scalable systems. So it's not just a little new toy anymore. Happy to share that with you today. Let me tell you about some of the patterns that we see a lot and that we want you to be aware of when you start building. I already mentioned you can bring your own code. And it's not just about bringing your own runtime and your own code, like your own business logic. You can actually bring any library. We provide a set of libraries already in the runtime, but you can bring your own. So if you have Node, you can install modules. If you have Python, you can pip install any dependency, and same for other languages too. The resource model. So how do you choose the power, or the compute power, or the memory capabilities of your Lambda functions? I like to call it power because it's basically just a handle. So you can choose between 128 megabytes of memory all the way to 3 gigabytes of memory. But also remember, with that memory also comes more CPU capabilities and more network capabilities. So think of it as a power. So depending on how you want to use it, what you need to do, if you need to do in-memory computation, if you need to do basic, simple data processing, you can fine-tune the resource of your Lambda function. There are different ways of invoking a Lambda function, so I'm sharing more details about it. We say synchronous or asynchronous, and I'm sharing some details in the next slides. Let's not forget about authorization as well. We like to say that security is our top priority, so by default, when you create a new Lambda function, it can do anything. Okay, maybe it can call a third-party service if you configure it with the right credentials. But if you want to read a file from S3, our object storage, or if you want to read from a database, or if you want to do anything, literally anything, you have to provide, and you can provide, you should provide fine-grained permissions to that specific function to do something. So that gives you the power of controlling in your microservices architecture. Maybe you have 20, 25 functions. Each one can do one thing really well with the limited permissions to do only that thing. So if this function is not supposed to read a file on S3 or a record from your database, don't give it permission to do so. And you are kind of improving security with this least privilege approach, we call it. There are different ways also to author your Lambda functions, to code and to update your Lambda functions. You can use what you see is what you get editors. You can use your own local editors, of course. If you're more into the cloud native kind of movement, you may want to check out our AWS Cloud 9, which is a in-browser IDE for you to code directly in the cloud, to write and deploy and install dependencies and do whatever you want in the cloud. I'm showing you what it looks like later. We like to say that there are a few universal rights when you develop any kind of software, and two of them are monitoring and logging. So every time you console log or print or whatever language you're using, every time you print something to standard output, all those logs get sent to Amazon CloudWatch for you to inspect, to analyze, or to build analytics on top of it. And the other universal right is monitoring. So each Lambda function comes with its own metrics of number of invocations, average time of execution, and all these very specific metrics that allow you to do fine-grained monitoring and to understand what's going on in the system. Eventually, to build custom alarms, to send you emails when something wrong happens, or to build dashboards so that you can monitor the systems overall. I've mentioned that stateless is one of the keywords of today. Remember, since we are now kind of separating the compute power from everything else, because now our compute is part of a service, you want to make sure that your compute logic is as stateless as possible. So make sure that the event comes in, and you maybe store the output of your computation somewhere else in a database or in object storage, anywhere, but do not store the the current state of the system within your memory or your local file system. You can do that for caching. So you have access to a lot of the local resources, the RAM, and the local temp folder. For example, you can store cached data in there, but don't use it for storing the state. That's supposed to be stored somewhere else, so your stateless code can scale horizontally without dealing with state in each individual runtime. There are so many different ways to invoke your Lambda function. These are some of them. So I've mentioned a few already. Maybe you have an object storage, a new file has been created. Great, I want to invoke a Lambda function. Or maybe there is a NoSQL database where a new record has been created. OK, I want to run a Lambda function based on that event too. So there are now more than 30 or 40 different event sources. And this is what they look like on AWS. Let me mention a few more. Well, Amazon API Gateway, if you want to have a RESTful interface on top of your Lambda functions, API Gateway will generate events, HTTP events. We'll pass them to your Lambda function. Your function will generate a response, pass it back to API Gateway, which will pass it back to the client. Other use cases, if you're doing IoT or Alexa chatbots, that's a great use case too. You can trigger Lambda functions based on the interaction with IoT devices or with Alexa bots. And then we have the configuration kind of events as well. So maybe you're using code commit to host your code, similar to what you do with GitHub. And maybe you want to run a Lambda function when someone git push into the repo. You can do that. Or maybe you have a message queue like Amazon SQS, simple queue service. Or maybe you have an email service like Amazon SES, simple email service. So you can trigger Lambda function more or less anywhere here. And some of these tools also help you doing orchestration or doing decoupling of your Lambda function. So maybe you have two Lambda functions. You want the first one to invoke the second one. OK, that's an option. But maybe you want to use Amazon SNS, simple notification service, to push a notification into a topic and get a Lambda function be triggered when there is a new topic, a new message on that topic. So that's a nice way to decouple your Lambda function to make sure they can be independently updated and debugged and monitored as well. So adding these decoupling mechanisms really help you be agile and be flexible with your infrastructure. I've mentioned there are 2 or 3 different ways, actually 2. The third one is just a variation of the second. There is the synchronous way. If you think of a RESTful API, okay, the client, so whoever is generating the event, expects a synchronous invocation, synchronous response. So in that case, for example, in an HTTP request, your Lambda function is expected to return the result as soon as possible. And they will be synchronous, meaning the one creating the event expects to have a response right now as soon as possible. The asynchronous invocation, on the other hand, as I was saying, this is more about if you have a queue or if you have maybe a topic where you want to push messages. In that case, if you think about it, the client putting the message in the queue or in the topic or maybe uploading a file on S3, they shouldn't care about who is processing that piece of data. They shouldn't care about what that new message or that new file is triggering, if that's triggering a Lambda function or not. So that's a nice way to decouple. So you have a sort of buffer of requests, and we will take care of invoking your Lambda functions under the hood. And that's useful because since we take care of that, we can also take care of retry policies, for example. So if your Lambda function fails, maybe there is a third-party service, you have some rate limiting through another API, we take care of retrying that event at least once. And if that doesn't work, you can then store the event somewhere, maybe in another queue for later reprocessing. That's an option. The third pattern is to have the stream-based. It's very similar to the asynchronous one, but instead of being given one event at a time, you're given a list of records or a stream of records to process. You can choose how many, the batch size, from 1 to, I think, 500. So that allows you to do batch processing if you have specific tasks or validation tasks or maybe machine learning kind of compute that work on a batch fashion. So that allows you to do that as well. And these are the services. So maybe you're using Dynamo or Amazon Kinesis that gives you the stream kind of functionality, or maybe you're using Amazon SNS or S3 that gives you the decoupling between event generator and event consumer. I want to spend a few more words about Amazon API Gateway, because I've mentioned already it's the service that gives you a RESTful interface on top of all your Lambda functions. But it's not just that. Okay, by default, API Gateway comes with additional features around security and, for example, DDoS protection. So if you're using API Gateway to reach a global audience around the world, there is a built-in CDN, a content delivery network inside API Gateway that will care of distributing your content and optimizing latency worldwide. And in that case, it's also protecting you from distributed denial of service attacks. So that's quite a nice thing to have. You don't want to be DDoS by anybody around the world, and it's good to have it built in. It also gives you more fine-grained control about authentication and authorization. So you can really have control about who can invoke this specific API or this specific path, or even this specific method of your API. You have very fine-grained control of that. And then it gives you additional controls about throttling and rate limiting if you want to say, OK, this user can invoke me, but only 5 times per minute. If they try to invoke it more often, throttle their invocation. So you have this kind of control as well. This is what the API gateway, it looks complicated. Let me show you piece by piece. So there are 3 different API endpoint types that you can use. So the first one is the edge optimized one, the one that I just described, which comes with a built-in CloudFront distribution, which is a CDN, a content delivery network. And what it means, why edge optimized? Because it's optimized for a global audience. If you want your APIs to be accessed by anywhere in the world. There is a second API endpoint type, which we call regional, the one here. And this one doesn't come with a CDN. So it's meant to be invoked by a specific region. So if you deploy your Lambda function or your API to maybe Dublin or Frankfurt or Paris, okay, if you call that API from Australia, okay, their request will have to go all the way to Paris. There is no global distribution. Eventually, you can add your own customer-managed CloudFront distribution on top and do kind of both access patterns, but that's up to you. There is a third invocation type, API endpoint type, which is the private endpoints. So the first 2, the endpoint that we generate, they are publicly accessible. You have all the tools to make sure that people need authorization and authentication to invoke them, but by default, they are public. If you want these endpoints to be private, only accessible by specific virtual private network, our Amazon VPC service, you can define these private endpoints. So they are supposed to be used from within an Amazon VPC, a virtual private cloud. So this is what happens in front on the client side, on the API consumer level. Let's see what happens behind the scenes. So this is API gateway, and you can optionally add caching mechanisms. So you want to cache the response of your APIs eventually, and there is like a 2-click configuration for that. You have all the built-in CloudWatch monitoring about which invocations and all the metrics, how many invocations per minute, and so on. But then under the hood, who can be the backend of your APIs? Well, today we are talking about AWS Lambda up there, but basically you can put anything behind your API gateway. It could be another service deployed on EC2. It could be another AWS service directly. So maybe API gateway can put data into Kinesis or write a file into S3. That's also possible. But literally any publicly accessible endpoint can become the backend of your APIs. So it's a powerful service. It's not only for serverless applications, which is what we're talking about today. So think about it. Eventually, you can even have API gateway to stay in front of your private data centers, your on-premises applications. So it might also be useful, for example, in a migration scenario. You are migrating to the cloud. You can add API gateway in the middle and make sure that you route the new traffic to your new deployment in the cloud. That's an option. OK, when we talk about modern applications, we have Lambda in here. So, but usually you don't have one Lambda functions. OK, maybe you have 3 at some point. You have 15 or 50. And what happens is that some of these functions will interact with the database. Some of these functions will maybe read or write events from a queue. Maybe some of these will even interact with legacy or on-premises services. So it can become kind of interesting to handle, to view the system overall, to orchestrate the system overall. And that's why we released a new open source specification that we call the Amazon States language that allow you to define a state machine. What is a state machine? Something like that. Okay, this is a flow. If you think about it with a starting point all the way to an end point, these state machines allows you to define a kind of, you can think of it as a data flow or as a logical flow of steps that need to occur or not. Maybe in parallel, maybe with an if condition, maybe if a step fails, you want to go back and do something else. So you can implement all these orchestration logic of your individual Lambda function. So each step, each green step and white step here is a Lambda function. You can have waiting states, you can have loops, you can have retry logics, and this service, which is Amazon Step Functions, allows you to do orchestration at a higher level. So think about it when your application starts to become kind of larger. This is an example of what you can do with Step Functions. Last year, I used Step Functions to create a state machine to understand how to tune the power of my Lambda functions. So it's kind of like a recursion here. But the idea was that how do I choose if my function, in order to be optimal as far as timing and pricing and cost, should have 128 megabytes or a gigabyte of RAM. Cool, let's be data-driven. Let's build a system that takes a Lambda function as input, runs the function a few hundred times with different configuration, and comes back with statistics about consumption and pricing and execution time. So this allowed me to be more data-driven and to use an orchestration tool to solve this problem and automate it. You can use this to automate your CI/CD pipelines as well. Which brings me to the next topic, continuous integration and safe deployments. What we mean by continuous integration, it's basically how you think about delivering and bringing your new code, your updates, your new features, your bug fixes, anything you're developing as part of your product to production. You want this to be safe. You want this to be quick, hopefully automated, so you don't have to go and change the production environment manually with a terminal or stuff like that. So let me show you how you can do that. But first, I want to agree on the concept of safe, because we've been doing this since software was born, right? You have a production system, you want to update it. Here today, we want to raise this safety kind of bar. So let's agree what we mean by safe and what you can do to make this process safer. So you can do all sorts of things, from pair programming to unit tests to local integration tests, all the way to code reviews. You can add all these best practices to your team, and this really helps you. You can go all the way to continuous integration, which means you build automatically and maybe run tests automatically whenever you have a new update, all the way to continuous delivery, which means you deploy these builds all the way to some sort of production or pre-production environment. Maybe you have some pre-production integration or even human semi-automated acceptance tests, and then you go on, and let's say the final result, the ultimate result that you want to achieve is continuous deployment, where every change that you git push or that you push into your version control system is automatically updated all the way to production without human intervention. Okay, that is the ultimate automation here. Let's see how we can get there and how we can make it safe. There's a problem. How many of you in the last, I don't know, 12 months have debugged or fixed a production environment manually, like SSH? Nice. Okay, it's not fun, okay? You do not want to be that guy there. Okay, you've probably seen this animation already. Okay, when there is a production system running, you don't want to be there trying to fix bugs before the customer hits the problem, okay? Because that's what you end up doing. And it's not fun. You don't want to be that guy. It's fun to watch, but when you're there and it's 3 a.m., you don't want to be there. And you then end up doing all sort of tricks and magics there. It's an educational process, but you don't want to be there more than once or twice. Sometimes it goes really well. Okay, you feel like, hey, I did it. It's great. You feel like a hero, like a ninja. Sometimes not really. You're like, yeah, this is what I need to do, and it just crashes on you, and you don't want to be there. So let me tell you what the automation pipeline looks like to avoid these kind of situations. We like to say there are 4 different phases, from your source control to your automated build, to your automated tests, all the way to the production environment. When we say continuous integration, we usually stop at the build phase. So if you're using Java or .NET or any compile language, you want to build an artifact that is deployable. You want to go all the way to continuous delivery, usually with a manual step or kind of human intervention step before going to production. As we were saying before, continuous deployment is where you just deploy all the way. How do you do that? On AWS, there are a few services that help you. You can start from AWS Code Commit or GitHub, if you prefer, to host your code, to host your Git repository. You want to automate the build and the test steps with AWS CodeBuild. Of course, each one of these steps is replaceable. If you are more familiar with Jenkins or with other tools, you can integrate them as well and make them part of the pipeline. Maybe you have third-party tooling like, I don't know, Python unit tests or Jasmine for JavaScript, like your own testing framework, and you can run your tests with CodeBuild as well. And then you want to go and finally deploy to production. Once you're sure that the integration test, the unit test, everything is fine in your pre-production or testing environment, you want to deploy. And we can use AWS CodeDeploy to deploy everything. So traditionally, CodeDeploy has been used to deploy to traditional environments like Amazon EC2 or Beanstalk. But today I will show you that we recently announced that you can use AWS CodeDeploy to deploy your Lambda functions as well. And that's the trick about making your deployment safe. I'm going to show you what it looks like. But how do you orchestrate this kind of CI/CD pipeline? Guess what? We have a service called AWS Pipeline that allows you to define the different staging environment, testing environment, production environment to understand which tests and which steps need to run before you actually deploy to the environment. If this is not enough for you, we have customers that needed to have more control around their CI/CD pipeline. You can use AWS Amazon Step Functions, which is the orchestration tool that I showed you, to build your own CI/CD orchestration pipeline. If you are curious, there is a link on GitHub, and you can check it out, maybe customize it, and use it to deploy your code to production. The way we do infrastructure as code as AWS is through CloudFormation. Okay, this is SAM, the sample, the serverless application model. It's also QSquirrel, but today it's the serverless application model. And SAM is a, let's say, it's an extension of CloudFormation that allows you to do infrastructure as code. So you define your application as a template, and with that template in your hands, you can go and deploy it to different AWS accounts or to different AWS regions or to different environments. So this allows you to have a standard way of defining the application and a reproducible, very easy to maintain, versionable definition of your application. So SAM allows you to go from this very large amount of code to define your serverless application to a much simpler, easier to read template. So this is what the AWS serverless transform looks like. You can define your AWS Lambda functions. You specify where is the handler, what is the runtime, like Python, Node, Java, Go. What are the access policies? What are the events triggering your function? In this case, it will be a proxy, meaning every endpoint will be handled by this Lambda function. And there are three serverless resources that you can use. The serverless function, that gives you a much easier way with respect to the AWS Lambda function resource to define your functions. The serverless API, which gives you a way to define API gateway kind of resources and methods and so on, eventually providing a Swagger template. So if you are already using testing or API definition tools that use Swagger, you can just import the Swagger template through AWS SAM. And then eventually also a simple table, in which this is a DynamoDB table, but with very, very simple specification, like what's your read and write capacity. So how many requests, read and write requests can handle that table by every second. So this allows you to simplify your serverless application definition. If you want to develop locally, you have AWS SAM CLI, which is a local development and debugging tool that will emulate Lambda, will emulate API gateway in your local machine. So you can do local integration tests or local unit tests on actual API endpoints and actual serverless functions. Both AWS SAM and AWS SAM CLI are open source on GitHub. So if you want to read the roadmap or contribute or fix a bug or even notify us of a bug, please open a new issue on GitHub. OK, let's try to now raise the safety bar. We want to make sure that this CI/CD pipeline with all these tools that we are seeing is safe. What do we need? Well, we want a way to define all of this in our infrastructure as code. So we want to keep that best practice. We want to be able to monitor and to look at the metrics and be smart about it, maybe react based on the numbers during the deployment. We want to have data-driven strategies, so different strategies that we can choose to actually do the deployment. And maybe we want to customize what the system, how the system works and how the system behaves based on our own hooks. So maybe we do that a lot now with AWS services. Maybe we have a built-in set of features, but if you want to extend it, we allow you to hook a Lambda function and extend the behavior of the service. So maybe you want to do that during our deployment as well. And maybe, and this is key, we want to be able to roll back if there is any error during the deployment. That's how you manage to sleep at night. That's how you can tell your developers, just git push. Worst case scenario, we roll back automatically based on errors and metrics and data. So that's the safety bar. That's how we are raising the safety bar. We're going to use the CodeBuild service, which I already mentioned. It allows you to define a specification file, a build spec file, where you define what needs to happen during the build phase. And this is what it looks like. So you have some environment variables as input. You have some install commands like npm install or pip install. Maybe you want to do linting, you want to do testing, and once you have run everything, you want to generate an artifact that is ready to be deployed. So in our case, we want to package our functions and our everything, our serverless application through CloudFormation, and the output of that command will be used by CodeDeploy to actually go and deploy everything for us. So today I'm going to demonstrate to you what it looks like, what this new feature looks like. And this new feature allows AWS CodeDeploy to take your new code and deploy it in parallel with like a completely independent version of it and do traffic shifting. That's what we call traffic shifting. This feature allows you to do blue-green deployment, where you have the old version and the new version of the code there, live, both of them. And you can say, OK, just send maybe 10% of the new traffic to the new version, just to see if it's working well and if it's generating any error. Since we are doing this, and we manage that process for you, we can also roll back and say, OK, go 100% back to the original version of the code that used to work fine. Eventually, you can add you can add pre or post deployment triggers through another Lambda function. So you can say, hey, before you give any % of the traffic to the new version, run this function, just as a whatever you need to do. And maybe after, when everything went smoothly, you want to run another Lambda function in the post traffic hook. Maybe to sync, maybe to post a hey message on the chat, or maybe to sync with a third-party deployment management tool, or anything that you like. How do you actually manage how the deployment and how much of the traffic is given to the new version? We have different strategies. So for example, today we are going to use this linear 10% every 1 minute. What it means is that every minute you give 10% more traffic to the new version. Okay, so in 10 minutes, we are done. If halfway, if at 30% of the traffic there is an error, we roll back to 100%. But you can choose other variations. For example, the canary. You can say give 10%, canary 10%, 30 minutes. You give 10% to the new version for 30 minutes. If nothing bad happens, you just go all in with a new version. So you have different strategies. You can even specify and build your own. And this is what it looks like in the console. So you start rolling out 10% of the traffic to the new version, and you have this traffic shifting step that will take a while, depending on the strategy. At some point, you will get to 60-40, maybe 50-50, all the way to 100. Okay, this is the everything went fine, no bug was introduced case, which is great, but bad thing happens. So I want to show you what it looks like when you deploy a bug to production, and it was not supposed to be there. So let me show you what it looks like. I need mirroring. Give me a sec. OK, so I'm going back to the AWS console. I am using AWS Cloud 9. which is our cloud-native code editor, IDE, where we have both our code and a terminal that we can use as if we were in our local machine. The best feature of Cloud9 is that there is a machine running under the hood that helps us with the terminal, but it switches off automatically if you don't use it for 30 minutes. So what's happening right now is that the machine is spinning up again with my environment, with my code, with my terminal. There we go. So here I have an application. It's a serverless application, as we were discussing before. There is a simple table. There is a serverless function here. This serverless function is triggered with a /test resource. So I will be creating an API with a /test get method. I am configuring the safe deployments with a linear 10% every 1 minute. And I'm monitoring the deployment using 2 alarms. So an alarm is something that triggers if a specific metrics hits a specific threshold that you specify. So here I'm monitoring the alias and the version, just everything that can happen. And here I define the two alarms. And that's all. That's my application. It's not doing anything crazy. This is what the code looks like. This is a Node.js function, which is reading from a DynamoDB table and returning back the message. So doing nothing crazy, but I want to show you what happens when we deploy a bug to production. So let's start invoking the system to show you what it looks like. So save deployment. There we go. So I have a script that will start polling the system. Somewhere. OK, let me go and find the URL. So this is my stack in CloudFormation. I have an output. This is the URL of my API. So I can invoke it, and it's going to tell me something like message OK. Can you see that? Message OK. So now I'm going to bash scripts poll, and I pass the URL. So I have this script that will be polling my API maybe a couple of times a second, just to show you that it's working. And then I have another script that will be tailing a local log file with the output of each individual invocation. So message OK, everything is going smoothly. Now, let's go and break our code. OK, let's do something really bad like throw new error. OK, don't do this in production. This is probably not going to happen if you have unit tests and code reviews and peer programming. OK, people don't do that. But we are on stage. We have limited time. So let me show you what breaking production with a new error looks like. So let's just deploy to production. Scripts deploy. So I'm skipping all the best practices here. I'm not asking a peer to review this. I'm not doing a code review. I'm not even Git pushing. I'm just deploying. So don't do this. But I want to show you the worst case scenario ever. 100% bug in production without CI/CD. Just to show you how you can be safe there and be tolerant to that scenario as well. So what's going to happen is that this is our CloudFormation console. And in a few seconds, I'm going to be shown that, OK, there is an update in progress of my stack. And if we wait a couple of seconds more, there will be a live deployment dashboard created for me that I can just click and see what's going on. OK, there we go. The code deploy deployment started. And we can see that we should already have 10% of the traffic allocated to the new version. See? But now if I go back to my terminal, in my polling, it's still polling. And now I can see that more or less one invocation every 10 should be failing, right? Because I'm using linear 10% every 1 minute. So 10% of the traffic is going to a new version of my code, which fails 100% of the time. So more or less 10% of the invocations, we expect them to fail. What will happen is that at some point, the alarm that we configured will trigger and will tell CodeDeploy, hey, stop, there is something wrong. Just bring the code back to the working version. Let's see if that happens or when it happens. So as you can imagine, you want to have, in a real world scenario, maybe your bugs don't really fail 100% of the time. So you will not have 10% failing invocations in production, right? Maybe your bug fail 10% of the time. So 10% of 10% means you have 1% failure rate in production for 1 minute. That's probably acceptable, depending on your rate. If it's not on your load. If it is not acceptable, you can build a different kind of data-driven approach. Maybe at Amazon, we do like 0.0001% of the traffic for a few minutes. That's more than enough to see if there is an error that impacts our customers. OK, you can already see that OK now is happening 100% of the time. If we go back here, OK, we already rolled back 100% to the previous version. The deployment is canceled due to an abort request. That's what we say. And if we keep refreshing our CloudFormation stack, the rollback is already finished. So we safely roll back to the previous version without human intervention and just with a data-driven check on the live traffic. So that's pretty cool. As I mentioned, this is probably not happening in production because you're a good developer and you have CI/CD pipelines, you have code reviews. So maybe you can tolerate 1% error rate in production to automatically roll back if there is any problem. That's what I wanted to show you today. I hope you enjoyed breaking production. Reminder, you can get your $200 AWS credit if you got scanned already. If you didn't get scanned, maybe you're out. Make sure you're scanned and take your $200 credit. We're going to have other sessions today and tomorrow and the day after tomorrow. So thank you for being here.